Hello everyone, welcome to this class. In this class, we're going to deal with substitution in formula. First, let's define a formula. A formula is an equation in which letters represent quantities. So what we're going to do in this class is the everyday mathematics we deal with, where we have a formula and we are given the parameters of the formulas and we are being told to look for the subject. So let's look at it this way. This is example 9. We are saying use the formula A equal to 1 over 2 BH. What is 1 over 2 BH? That's like area of a triangle. We already know that one. To calculate the area of a triangle, okay, it is written here. You understand? So now we look for this A by knowing what these alphabets are, these letters are. So that is exactly what we are doing. So let's go for it. First, we say the base is 3.2 cm and the height is 5 cm. So what's the base? Base is the B and height is H, and we're looking for the area. So let's go for it. We have it that area is 1 over 2 times B times H, which is 1 over 2 times our base is now 3.2 times what? Height, which is 5 cm. So by the time you solve this using your calculator, you are going to get that your area is what? 8 cm. So we are not giving we are giving cm, so it will be cm square. That's really because this is cm, this is cm. When the two cm multiply by each other, they will have cm square. Let's go to number B. This is A. Let's go to the B part of it. So the base is 4 kilometer and the height is 600 meter. So we have A is 1 over 2 times base. In this case, we have 4 kilometer. 4 kilometer is like 4,000 meter. So we have 4,000 meter times 600 meters. So it's either we are converting it to meter or we are converting it to kilometer. In my own case, converted to meter. So by the time you multiply this, you have 1 over 2 times this, you have 2,000 times 600. So you'll have 1250, right? Kilometer squared. Or if you want to convert it to kilometer squared, divide by 1 million, that will give you 1.2 kilometer squared, right? So for those that are wondering how I was able to do this, another way you could have solved it. Let's say I didn't have to convert, I have to solve direct. This will be 1 over 2 times this is 4 kilometers. So I have 4 times this 600 meters. To convert 600 meters to kilometer, you have to divide it by 1000, right? So 600 divided by 1000, which will give you 0.6. So by the time you multiply this out, this divided will have 2 times 0.6 will give you 1.2 kilometer squared. So either way you solve it, you are getting the same answer. Here, how do I know? Here, if you want to convert to kilometers, you just divide by 1 million, as I said earlier. So let's go to the next example. Example 10. We have it that the sum of a square of the sum of the squares of the first n integers is given by the formula. This is sum of n, square of n integer. This is the notation for it. S subscript n is equal to n into bracket 1 plus 1 bracket close bracket open 2n plus 1 bracket close, all divided by 6. So what you're trying to say is that the sum of squares, this is the formula used to, like when you have, square is simply a number multiplied by itself, right? You have something like 1 multiplied by itself, you have 1, 2 multiplied by itself, you have 4, 3 multiplied by itself, you have 9, 4 multiplied by itself, you have 16, and so on. Let me say till n. N is wherever we want to stop. So you're being told that the sum of adding all these squares is given by this formula. So you're being told to calculate the sum of S20, meaning the sum of adding the squares till you reach 20, because this is for 1, 2, 3, 4. You keep counting 5, 6 till you reach 20. So all we need to do is just substitute 20 into this formula. So in that case, this Sn Let's solve for A. We'll turn to S subscript 20, meaning that we are stopping at 20. So we have 20 into bracket 20 plus 1, bracket close. Then you have 2 times 20. I'm putting the 20. Anywhere I see N now, replace it with 20 plus 1, all divided by what? 6. So if I open up this, I'll have 20 times what we have here is 21 times what we have here is 2 times 20 is 40. 40 plus 1, 41, all divided by what? 6. So this will give me, by the time you divide, you cancel out with 6 and solve for this, you are going to get something like 2870 as your answer. So what it means is when you start adding 1 times 1 plus 2 times 2 plus 3 times 3 plus 4 times 4 till 20, this is what you are going to get. So let's go to the B part of it. The B part says the sum of the square from 21 to 40 inclusive. You know, when we are dealing with a number, you are being given a range and you have the word inclusive, it means those two ranges are also included. You know, when somebody tells you to look for something between, let's say you are really told to look for something and you are really told between 1 to 10, meaning between means from 2 to 9. But we are still told between from 1 to 12 inclusive. You can now know, okay, you are actually checking it from that 1 to 10. So in this case, we know that we are talking about what they say we should look for here, the sum of the squares. Like we are going to start with 21 times 21 squared plus 22 squared plus 23 squared till we reach 40. Now the best way to go about this is simply to find the sum from 1 to 40 and also find the sum from 1 to 20 and then subtract. Are we together? Because if you say you want to find the sum from 1 to 40 and then you now say, because this notation you will use for it, you have to do something like S40 minus S20. So you have to find this sum using this formula we already solved here and this sum, and then subtract the total you got from here, to be left out with the total. Mind you, you see that this is 20 instead of the 21 that was given as inclusive. You get? So the idea is that from 1 to 40 is already including all the total from 1 to 40. But from 1 to 21 is including the total from 1 to 20. If you increase this to 21 and subtract, you will miss out the 21st value. That's why we are reducing it to 20. Let me give you an example. If you are being told to find the sum, we have sum 1, 2, 3, 4, 5, and you are being told that find the sum. Are we together? Let's say from the second to the fifth. You know, when you add this, you are getting 14. You understand? But let's say we went to go and do S5 minus S2. From here to here will give you 3. While from here to here will give you 15. So by the time you do 15 minus 3, we are getting 12, which is less than the 14. So the best thing to do is to go to S5 minus S1. So that you now have 15 minus 1, because the sum of 1 is still 1. While the sum of this is still 15. We'll give you that same 14. That's what we did. We have to step a little step down. Instead of using S40 minus S21, we are using S40 minus S20. I just hope we understand it. So if we are going to now solve into the formula, we now have something like S40 will now be S40 is 40. Anywhere we see N, we replace it by 40. 40 plus 1. 2 times 40 plus 1, all divided by 6. Right? While S20 will give us, anywhere we see, okay, we already done S20 before, so we don't need to. Let me solve for this. This will give me 40 times 41 times, because this plus this 41, 2 times 40 is 8, 80 plus 1 is 81, all divided by what? 6. So by the time you solve for this, S40 will now give you 22,140, right? And because we solved for S20 before, I will now do S40 minus S20 will give you 22,140 minus 2,870. So your final answer is 19,270. So very simple. Let's go to the next example. Example 11. The formula F 9C over 5 plus 32 shows the relationship between temperature in degrees Celsius, in degree Fahrenheit F, and degree Celsius C. Find F when C is 40 and C when F is 100. The temperature, then C, the temperature when F is C. So let's go for it. Solution. We are given the formula F is equal to 9C over 5 plus 32. And this simply shows that when F, this is F, I put together. If you have a degree Celsius and you have to convert it to Fahrenheit, this is the formula you are going to use. So let's start for the first one. First one says find F when C is 40. So let's go for that. This is F. Anywhere we see C, we replace it. Okay, let's go A. You replace it with 40. We have 9 times 40 all over 5 plus 32. This is the same as, let's say, 9 times 8, because 40 divided by 5 is 8 plus 32. This will finally give you 72 plus 32. And your answer is 104. This is degree Fahrenheit, though. Degree, you can write the unit degree Fahrenheit. This is the first one. Then the second one says find C when F is 100. That's very simple. In this case, you are going to do what we call reverse substitution. You already have this formula that F is 9C all over 5 plus 32. Now, instead of give us F and C to look for F, we are giving F to look for C. So the thing you're going to do now is, where you see F, you represent what they give you, and then try to solve for C. So what you're going to have here is something like 100 is equal to 9 times C over 5 plus 32. So that's what we are solving. So the next step will be 32 will come to the equation. Or will I rewrite it as, let me write this as, because C is what we are looking for, so let me write this as 9 times C over 5 plus 32 is equal to what? 100. Are we together? So 32 cross this equation, we now have 9 over 5C is equal to 100. When 32 cross equation become minus, because it's plus here, minus 32, which will give us, when we solve for 100 minus 32, we are going to have, or another way we could have solved it easy is to multiply everything by 5, but I think we didn't go through that route. So let's continue what we are doing to get something like 68. So 9 over 5 is giving you what? 60. Okay, 9 over 5C is giving you 68. So in that case, C will be 68 times 5 over 9. You know what I did? Because you have 9 over 5 here, you are reversing it. Here will now be something like, let me say write it here. 5 over 9 times 9 over 5. This is what we have. So multiply both sides of the equation by 5 over 9 and 5 over 9. That's what we did. So that will make this C, the quotient of C, to just be 1. So here, C will now be 1. You are going to have that C is now 1, because this will cancel out to give you 1. But coming to this side, you're going to have 340 over 9, which if you convert it to mixed fraction, you have 37 whole number 7/9 degree Celsius as your final answer. Then the number C of this, the temperature when F is equal to C. So what they are trying to say is that in this formula, this F now is now C. What will be the temperature at that point? So it means anywhere you see F, you represent C. So that's what this substitution is all about. Anywhere you see a value, represent it with the value given to you. So you have, this of also have F equal to 9C/5 plus 30. We are now having C because we are told that F is equal to C, equal to 9C/5 plus 32. To make this easy for me, I'll multiply everything by 5. I will now have 5C. When 5 multiply here, when 5 multiply, you have 9C plus, when 5 multiply 32, I have 160. So this C will cross the equation. I have 5C minus 9C, because it's positive here. When it cross, become negative, equal to 160. I'll now have 5C minus 9C will give you what? Minus 4C is equal to 160. So divide both sides by minus 4 and minus 4. You now have that C is equal to what? Minus 100 and, sorry, minus 40. But 160 divided by 4 is 40. But meanwhile, we are getting C as minus 40. But mind you, you are being told that F is equal to C. So at the same time, F at this point also is also what? Minus 40 degrees. In this case, you can say it's degree Fahrenheit. In that case, you can say it's degree Celsius, depending on the angle you want to look at it from. So what they directly told us is at what point is Fahrenheit and Celsius equal to each other. That is indirectly what we just did in this class. So let's go to exercise 6E. Number 1, it says if y is equal to 2x squared minus 5x minus 3. Find the value of y when x is minus 1. So let's start doing it. When x is minus 1, you have y is equal to 2 minus 1 all squared minus 5 minus 1 minus 3. So when we solve for this, we have 2 times 1 minus 5 times minus 1 is plus 5 minus 3. So we have 2 times 1 is what? 2. 2 plus 5 is 7. 7 minus 3 is 4. Let's go to the B. When x is 0, you just have y is equal to 2 into 0 all squared minus, and replacing all the x with 0, 5 into 0 minus 3. So this will give us 0 squared is still 0. 0 times 2 is 0 minus 5 times 0 is 0 minus 3. So the answer is minus 3 in this case. Let's go to C. When x is 1, we have 2 into 1 all squared minus 5 into 1 minus 3. So 2 times 1 square is 1. 1 times 2 is still 2. So you have 2 minus 5 times 1 is minus 5 minus 3. So 2 minus, okay, this minus 5 minus 3 is minus 8 plus 2 will give you what? Minus 6. We go to D. When x is 2, we have y. Okay, I made a mistake again. 2 into 2 all squared minus 5 into 2 minus 3. 2 squared is what? 4. 4 times 2 is what? 8. Minus 5 times minus 5 times 2 is what? Minus 10. Minus 3. 8 minus 10 is minus 2. Minus 2 minus 3 is minus 5. So in the last one, you have E. Y. X is 3 in E. So we replace by 3. 2 into 3 all squared minus 5 into 3 minus 3. So 3 squared is 9. 9 times 2 is what? 18. Minus 5 times minus 18 is what? Sorry, minus 5 times 3 is minus 15. Then minus 3. 18 minus 5 is 3. 3 minus 3 is what? 0. So that is that for this part. Let's go to the next example. So exercise 6E number 10, we have the formula D is approximately, this thing is a sign of approximately 5 into root h over 2. Now let's solve. Distance D in kilometers, so this D is always in kilometer from what they said, of the horizontal, which can be seen from a point h in meter. This h is in meter above the ground level. So this is the formula. Oh, I didn't start from here. The formula D 5 into root h over 2 gives the approximate distance. Then I read the rest earlier. So find the approximate distance of the horizontal from the top of the building 72 meter high. So if you have A, you are looking for D when h is 72 meter high. So you just simply have replace anywhere you see h by 72. That's 72 over 2. So this will also give you, this will be equal to 5 into bracket 72 over 2 is what? 36. We all know that the square root of 36 is what? This is the same thing as 5 into bracket. Square root of 36 is what? 6. Or let's say 5 times 6. So the final answer for this one is 30 kilometers. Don't forget, we have been told that D is in kilometer. So let's go to the second one, B. From the top of a tower, a student can see far about 35 kilometers. How high is the student above the ground? Meaning, we are now in this case, we are giving D 35 kilometers, but we are now to look for H. So our formula will now look like this: 35 is equal to 5 H over 2. So we are now looking for H. Are we together? So in that case, let me rewrite this equation as 5 into H over 2 is equal to 35. It's the same thing. I just brought this on here, brought this on here. So in that, it will now have square root of H over 2 is now, when you divide both sides of the equation by 5, now 5 divided by 5, 35 divided by 5. So we are now left with h over 2 at this side of the equation. So this would cancel out to be 1, while at this side of the equation, you are now left with 7. So we are still looking for h. So what's the next thing we are going to do? We square both sides of the equation. Square, square. So when we square this side, this square cancels out the square root. So we are left with h over 2 is equal to 7 squares is what? 49. So when we multiply both sides of the equation by 2, we have h over 2 times 2 equal to 49 times 2. So this cancels out to give you h is equal to 49 times 2. 2 times 9 is 8. Carry 1. 2 times 2, 8. We have 92. Mind you, it will be in meter. We have been told that h is in meter while the distance is in kilometers. So that's solve for our final question for this class. But I want to also put us through in this here for those of us still having a confusion. This side, we have that we have been told to look for the sum from 21 to 40 inclusive. The reason why we have to do that of 40 and 20 instead of 40 and 21 is because remember what I told you. When you're looking for sum of a number, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I have been told to look for the sum. We are being told to look for the sum from 4th to 10, both of them inclusive. Mind you, when you look for the sum for 1, 2, 3, 4, the total sum you have is also including the sum of these 4. And when you look for the sum to 10, the total sum you have is also including the sum of these 10. Mind you, we are looking for inclusive when the two are inclusive. So if you just go and do S10 minus S4, what happens is that you are subtracting what you get from 10 from what you get from 4, meaning that this 4 also it has been subtracted out. So you are now counting from 5 up. It will be wrong. But you have been told that both are inclusive. For those that will ask, why didn't we go up for 10? You don't need to go up for 10 because you already have the sum of 10 you are looking for. Those that will ask, why don't we do something like S11 minus S since we are going low? No, you don't have to go that. So that's why we have to, in this case, we are giving 21, but we have to do it for 20. Meaning that you don't want to subtract out the sum of 21 that have been included. In this case, you are being told for 4. You have to start from 3. In this example I have here, you have to start from 3, so that when you now subtract, you are now subtracting the total sum of 10 from the sum of 3 down. So in that case, you also have the value, the sum of 4, and also the sum of 10 inclusive in it. So that's why you have to step. However, that's why you have to go a step down. But in this case, it still remains the same. I just hope this explains it. Thank you, and see you in the next class. Any question? Drop in the comment section.